Alright, so we've already learned how to graph exponential functions, and we've been doing that in 11.1. So now that you've learned what logarithms are, and we've learned how exponentials and logarithmic functions relate, we're going to go ahead and start graphing logarithmic functions. So the first big thing to note about logarithmic functions is they have the same traits as exponentials, and they have the same steps, basically. So the first thing to note is that they are inverses of each other. Hopefully we know that by now. So logs and exponents, those are inverses. Exponentials are graphs very similar to exponential graphs, except for they're approaching an asymptote that is going to be vertical instead of horizontal. So kind of instead of having pairs to the left and right, we're going to have approaching an asymptote this way. We're going to have approaching the asymptote from the bottom. We can have approaching the asymptote on the other side of it. And we can have approaching the asymptote again from the other side too. Very similar to exponentials. Exponentials always have a horizontal asymptote, whereas we're going to find logarithms always have a vertical asymptote. So vertical means that it needs to be x equals something, whereas horizontal was that y equals some number. Well, domain and range, an exponential domain was all reals. It was everything. But the range was restricted by the horizontal asymptote. So all you do for domain and range is we flip to get the domain and range of a logarithm. So the domain now is going to actually be based on the range. So that's the one that's restricted. So restricted by the vertical asymptote. Whereas now the range is going to become everything. So the domain becomes the range. So range is your negative infinity to infinity now. So again, you're flipping those ideas. So the general formula for logarithms, now that it's kind of hidden here, is you have your log base something, x minus c plus d. The same exact kind of things that happened with exponents happen here. So c tells us we're shifting left and right. So c is shift left and right, but it's opposite. So you got to make sure that you remember it's the opposite of what happens. C is also going to be your asymptote. So this is your asymptote for logs. Now D, it's on the outside, so remember, think that means going up or down, and that's how we shift. So a few things. When we graph, we're going to talk about the range, always, and even if the homework doesn't say it, you should do all of these parts. Range, again, it's always all reals. It's negative infinity to infinity. You can state that right away. Vertical asymptote, that's that value for c. Domain, again, is based on that c value. You exclude c, and then from the left or right, you have to figure it out. And again, we're going to use our calculator to come up with a table. Now, the only thing that's kind of tricky is we can only type in base 10 or e. Unless you have a new calculator, there is actually any base log. So only with the new calculator. That's like an 84 color, basically. If not base e and you have an old calculator, so here, This is the old, or kind of an 83 or older 84. You're going to use the change of base formula. So we're going to take log base b of a. It's going to be log of the inside on top, log of the base on bottom. And we'll get to an example like that. It's not actually example 3, it's example 2 and 3 in here. Alright, so let's actually go through, kind of formulate a way of doing these. So we have a logarithm. First thing, state range. Well, range is all reals. It's everything. Now we need an asymptote. So step 2, asymptote. There's no c value, so it's just going to be x equals 0. There's nothing inside. So x equals 0. So let's go ahead and graph that. X equals 0. I like to draw it right next to, against. It's hard to usually overlap that x-axis. Right? Now we need the domain. Well, the domain is going to be 0 to either infinity or 0 to negative infinity. That's where we kind of need to pop it in our calculator and see what we're going on. So y equals, hit the log key, again if you don't know where that is, all the way down here under x squared. Base 10, don't need to put anything in there, of x. Hit graph, and it looks like I start at 0 and I go to infinity. So domain is 0, we're not including it, and we're going all the way to infinity. So again, I did that based off the calculator and the asymptote. Now I need a table. While I graphed it, I just need to hit second table and get something. Again, you can see that error going on here. Shows me that I do not have any negative values here. So start my table. So x and y. I'm just going to show in here that 0 gives me an error. And then I'm going to start with 1, that's 0, 2, 0.301, 3.477, 4, we'll do 0.602, and I'll do one more point. 5, I have 0.698. Again, I took these straight off of my calculator. Now let's plot them. So 1, 0, that's there. 2.3, again, it's slowly going up. 3, slowly approaching 1. So I know I'm going off this way, but where am I going towards the asymptote? Well, exactly. You're going towards the asymptote, but you shouldn't cross it. And you should have kind of a more smooth curve than I was able to draw here, but you get the idea there. Draw a few points, make sure that you get that asymptote going in there. Alright, so let's talk about one where we actually have to change the base, or I can show you how the newer calculator can do it as well. So, base is not 10. So base not 10 or e. So you need to change this right away. So f of x equals, well remember, if we need to change something, log b of a becomes log of the inside over log of the base. And that's how we change it. So log of the inside, so we need log of x over log of the base, which is 2. And that's exactly how you'd enter this in your calculator. Well, first let's talk about domain and range. So range, negative infinity to infinity. Again, everything. Asymptote. Well, again, we're looking at that value on the inside, here or inside x. Nothing's in there, so again, it's x equals 0. And now I need to make my domain. Well, again, I'm not exactly sure how this graph looks, so I probably should put it in the calculator and figure it out. So if you have an older calculator, like the TI-83, you're going to go ahead and you're going to enter it like log of x over log of, well, I don't need 1/2 here, I need 2 actually. So log of 2. And then you're going to graph it. So again, we see it starts around 0 and it's going towards infinity. Now, if you have the newer calculator, you can go to math and arrow down, just keep going down until you hit log base. That means log of any base. So log base 2 of x is what I want. Now I don't even have to worry about changing base, and I hit graph. Well, again, we should notice here that these two graphs are the same exact thing. Same way. So domain, we start at 0, we're going towards infinity. So 0 to infinity. I did not plot my asymptote, but let's do that now. Alright. Asymptote's there. Now let's get a table going. X, Y. So I'm going to hit second graph to get a table here. Again, I have an error at 0, so just to show that 0, there's an error. And then let's do positive 1, 2, 3, 4, 5. So 1, 0, 2, 1. 3, 1.585, 4, 2, 5, 2.32, 2 for rounding. So now we can actually plot some points that are a little bit better. 3, 1.5-ish, 4, 2, 1, 3, 1.5, 4, we're at 2, 5, 2.3. So we're kind of going up here. So approaching, and then again, we're going to follow that curve down towards the asymptote. Alright, I'm going to leave this one here as a U try. That's basically the same exact process as this one, and you'll figure that out when you do it. So go ahead, you do that one on your own. We're going to talk about the last one because it looks a little bit different. So I see natural log there. Anytime you see natural log, you should think base E. Well, your calculator can do base E, so we don't need to change anything here. So start with range. Again, same thing. It's a log, so range is everything. Now, the asymptote, there is a C value. So we need to figure out what is the asymptote there. Well, you take x minus 1, set it equal to 0, and solve. So plus 1, x equals 1. That's your asymptote. Now how would I enter that in my calculator so I can find the domain? So now I need the domain. Well, I already entered it, but let me enter it again for you. Natural log is under the log key, so natural log, x minus 1. Well, you just put x minus 1, make sure you close your parentheses though. So let's graph that. Now, this is what's interesting. The calculators don't go ahead and they don't finish the graph for you. Do not copy your calculator like this. It should keep going. It approaches the asymptote, so make sure that you always continue the graph in both directions. Alright, so we saw that it looked like it starts at 1 and goes to infinity. So domain is 1 to infinity. Well, it's shifted with that asymptote, as we noticed. So asymptote at 1, now I actually have an asymptote that's not 0. Alright, and let's get a table of values going. X, y. So second table. Again, I'm going to look for the error here. Now, notice the last error happens at 1, because that's where your asymptote is. So 1, we've got the error, and then we're going to start with 2. And 2 is at 0. 3, 4, 5, and let's go to 6 for this one. 3, we're at 0.693. 4, we're at 1.098. 5, we're at 1.386. 6, we're at 1.609. Alright, so we gotta plot those points. 2, 0, we're at 3.6, a little bit above. 4, 1 point, so slightly above 1. And we're slowly climbing. So again, we're slowly climbing, and then we're going to start decreasing as we saw on the graph there, but approaching the asymptote. Again, notice how I continue my graphs in both directions, even though it doesn't show that in your graphing calculator. So you're expected to make sure that you show that. Alright, so again, go back, you try this one, or if you paused and you did it and then went on, go ahead and do that. But again, make sure you come to class with that prepared.